Okay, Oak Rovers, this is going to be a video that's going to help you with problem 816. It's the homework from Algebra Connections from section 8.1.2. And in order to be able to do the rest of the chapter, you've got to make sure that you understand how to do the basic generic rectangle and diamond problems to factor quadratics. So here we go. So number 16a, this video is just going to explain how to do number 16, and you're going to go through all four cases and make sure that you did them the same way that I've done them. So the first one, 16a, I want to factor x squared minus 4x minus 12. Right now it's written as a sum. I've got to write it as a product. Okay? So when I do this, I always put my bigger tiles down in the bottom left-hand corner. Those are my x squared tiles. So let's go ahead and make my x squared tile down there. And then I always put my unit tiles up in my upper right-hand corner. In this case, that's going to be negative 12. So I'll put negative 12 up in the upper right-hand corner. Now, a couple things that are kind of neat about this problem right now. I know by Casey's rule that the product of this rectangle and the product of that rectangle have to be the same as the product of this rectangle and the product of that rectangle. Now, I also know that this rectangle down here in the bottom right and the rectangle up here in the upper left have to add up to the middle term. And this is where my diamond problems come into play. I know that these two have to add up to something and they have to have a product of something. Because of that, I can put them into a diamond problem. That's why we've been doing diamond problems for the last year and a half, is to lead up to this factoring quadratics. So the product of these two rectangles has to be the same as this. So the product has to be negative 12 times x squared is going to be negative 12x squared. But the sum of these two rectangles has to add up to the middle term in my quadratic when written as a sum, which is negative 4x. So I'll put my negative 4x down there. Now what I have to do is I have to figure out what two things I can multiply together to get negative 12x squared and add together to get negative 4x. Well, they both have to be an x term, and in order to get a product of the negative number, one's got to be positive and one's got to be negative. And actually, when the sum is a negative 4, the negative one's got to be 4 bigger than the positive one. So if I look at that, the two numbers have to be negative 6x and 2x. Because when I multiply those together, I get negative 12x squared. And when I add those together, I get negative 4x. Now what I do next is put these two numbers back into my generic rectangle. It doesn't matter which one goes in which box. They can be interchanged. So for this case, I guess I put the 2x down here, so the negative 6x goes there. Now we're going to factor out what I can factor out in the bottom row. Well, they both have an x term, so I'm going to factor out an x. The area of this rectangle is x squared. This dimension is x. So I have to think what this dimension has to be, and x times x is equal to x squared. And the way you get the area of a rectangle is multiply the dimensions. So this dimension also has to be x. Since it's a rectangle, this dimension's x. This dimension up here also has to be x. So if this dimension's x and the area is negative 6x, this length has to be negative 6. If this dimension here is x and it's a rectangle, that means that this dimension also has to be x. My area of this rectangle is 2x, so this side length has to be 2. Now to write that as a product, I'm going to take x plus 2 times x minus 6. And that is this quadratic, which is written as a sum up here, and now I've written down as a product down here. And that's going to be an important thing to be able to do, because later in this chapter it's going to explain how that's going to help us graph a parabola if we're able to factor this quadratic. Okay, let's do the next one. Letter B. Again, my x squareds go down here. My units go up here. Now these two boxes have to be the rest of the sum. The rest of the sum is 4x. So the sum of these two boxes has to be 4x. But by Casey's rule, I know the product of these two boxes has to be the same as the product of these two boxes. Well, the product of these two boxes is 4x squared times 1 is just 4x squared. So the product has to be 4x squared, and the sum has to be the middle term, which is 4x. Well, 2x plus 2x is equal to 4x, and if I multiply 2x plus 2x, I actually get 4x squared. So that's what I'm going to put into these two boxes after I finished my generic or my diamond problem. Now let's factor out what I can factor out of this row. Well, 4 and 2 have a factor of 2 in common, and x squared have a common of x in common. So this is going to be a 2x is what I can factor out of that side. If this dimension is 2x, my area is 4x squared. In order to get the 4, I have to have a coefficient of 2. In order to get x squared, I need another x, so it's going to be 2x down here also. Well, if this is 2x, because that's 2x, this length has to be 1. And if this is 2x, because it's a rectangle and that's 2x, this length has to be 1. So I can write this sum as a product of 2x plus 1 times 2x plus 1. Or another way to say that is 2x plus 1 quantity squared. Let's go ahead and finish up the rest of these and move that out of the way. Let's finish off the rest of these. I do it the same way. My x squared tiles go down here. My unit tiles go up here. By Casey's rule, these two boxes have to have the same product as these two boxes. So let's go ahead and write that product of negative 10x squared up there. But these two boxes also have to add up to the middle term of my quadratic when it's written as a sum, which is negative 9x. Now what can I multiply together to get negative 10x squared and have a sum of negative 9x? I know since I have a negative product, one's got to be positive and the other's got to be negative. I know since my sum is negative 9x, the negative number's got to be 9 bigger than the positive number. So those numbers are going to be negative 10x and x. If I add those together, I get negative 9x. If I multiply those together, I get negative 10x squared. Put those into the boxes. In this bottom row, I can only factor out an x. Well, if this length is x and my area is 2x squared, this has to be 2x. If this length is 2x and my area is negative 10x squared, this length has to be negative 5. If this length is x and my area is x, this length has to be 1. To write that as a product and sum, it's going to be x minus 5 times 2x minus 1. Last one, put the x squared tiles down here, put the unit tiles up there. The product of these two is negative 24x squared. That means the product of these two has to be negative 24x squared. These two have to add up to the middle term when the quadratic's written as a sum. So these two have to add up to positive 10x. So these have to add up to positive 10x. Now in this case I have a negative product and a positive sum. Since the product is negative, one of the numbers has to be positive and the other has to be negative. Since my sum is positive 10, my positive one has to be 10 larger than my negative one. So it's going to be 12x and negative 2. Put those in the boxes. In this row, 3 and 2, the only factor of 3 and 2 is 1. X and x squared, the factor is x, so this is going to be x. If this is x, my area is 3x squared. That has to be 3x, because x times 3x is 3x squared. If this length is 3x, my area is 12x. This has to be 4. If this length is x, and my area is negative 2x, this length has to be negative 2. So writing that as a product, writing this quadratic, which is written as a sum up here, as a product, is going to be x plus 4 times 3x minus 2. And I think I have that right here. There it is. You might not be able to see it very well. There you go. X plus 4 and 3x minus 2. And that is how you use generic rectangles and diamond problems to factor quadratics when they're written as a sum. Hopefully this video helped. You guys got to know how to do this in order to do the problems in the rest of the chapter. You can see how important it is to know your integer rules. You know, a negative times a negative is positive. A positive times a negative is going to be negative. Those really, really are important when you get to this part of the math. Hopefully that video helped, and we'll see you tomorrow in class if you have any questions.